let's maybe list some powers of x. So x to the 4, we've got x cubed, we've got x squared, we've got x, we've got a constant, which is like the number 1, right? We've got maybe the number 0, we've got 1 over x squared, 1 over x cubed, and so on and so forth. And observe that if you take the derivative of x to the 4th, you don't get exactly x cubed, but you get a number times x cubed, right? It takes things with a 4th power to things with a 3rd power. And then if you take the derivative of x cubed, well, you don't get exactly x squared, but you get a number times x squared. It takes cubes to squares. It takes squares to 1st powers. It takes 1st powers to just the numbers, other than 0, and it takes numbers to 0. That's kind of the action of the derivative, right? But then notice that if you take the derivative of 1 over x, you get something like 1 over x squared. And then if you take the derivative of 1 over x squared, you get a number times 1 over x cubed. And then that's going to actually continue infinitely in that direction. But notice that there was in fact a hole in this picture until right now. And that hole is we needed something to take the derivative to get 1 over x, right? We didn't have that until right now, but now we do. It's the natural log of x. And you might say, well, oh, look, we just created another hole to get to the natural log of x. But as we'll kind of see later, you can actually find a combination of the natural log of x and x, which will take the derivative to the natural log of x. So that's not actually a hole. We'll worry about that later though.